also 0. So this one is indeterminate form. So going down my list of things to try, doesn't factor, and then our new things today, conjugates and trig identities. Certainly looks more like a conjugate question to me than a trig identity question. Now, you don't always want the conjugate of the numerator. You always want the conjugate of the part that has the square root piece. So I would like the conjugate of the denominator this time. Better multiply the same thing on top and bottom, so it's like you're really multiplying by 1. You still okay up to there? Okay. So in the numerator, I'm just going to say I've got x minus 2 times this, because I suspect this x minus 2 is going to cancel out. But in my denominator, I need to FOIL these two terms with these two terms. When you multiply your fractions, you multiply your denominators. 2 terms times 2 terms. You can refer to FOIL if you want to. So first part of FOIL, 1 times 1. I know the outer part of FOIL and the inner part of FOIL are going to cancel anyway, so I'm going to skip that. And then right here might be your mistake. But the square root of 3x minus 5 times the square root of 3x minus 5 would be 3x minus 5. But a positive times a negative means that this is negative. Not that 3x is negative, the whole thing is negative. A negative something times a positive something gives you the negative something. So if you only attach the negative to the 3x, then you're going to get stuck. So I would suspect that would be a common mistake there. Okay, down here I've got 1. I could distribute this negative. I could combine 1 and plus 5 to get plus 6. And then I know this needs to look something like this. So if I was to factor out a negative 3, do a GCF, now something cancels, the x minus 2's. And then I can probably finish with direct substitution now. Plugging in a 2 up here gives me 1 added to this one. Try to plug 2 in down here, but there's no x's left over to plug it into. So it looks like negative 2/3. So was it this, the negative?
Yeah.
Yeah. Yeah, especially when it's, I mean, I know that you guys know a positive times a negative is negative, but when there's more than one term, you have to make sure it goes to all of the terms.